Look at a few more applications for our derivatives and our rates of change. In question 8, the graph shows the influence of temperature on the maximum sustainable swimming speed of salmon. In case you were wondering, there you go. What's the meaning of the derivative of s prime of t? So this graph evidently is the temperature to swimming ratio for salmon. So when we're looking at our graph, it looks like when the temperature is a little bit colder, the salmon swim slower. When the temperature warms up a bit, they increase. But look what happens when it gets hotter, they slow down again. So it looks like, in case you're wondering, salmon's optimal temperature and swimming speed is in this range. So there you go. So what is the meaning of the derivative s prime of t? So the derivative means the rate of change. And this time, the derivative is our speed s with respect to time t. So this will be the change in the speed with respect to the temperature. So what's the meaning of s prime of t? The meaning of s prime of t is the change in speed with respect to temperature. Estimate the value of s prime of 15. Now this is very, very hard to do because if we're estimating the value, then that means we're looking at the graph and we are estimating the slope. So we are trying to draw a tangent at t equals 15. So drawing the tangent line, freehanding it is very hard to do. We are just going to do the best that we can. We're going to follow the slope of the curve. 15 is right here. So that is our point we're aiming for. So if we follow the point of the curve, let's try to draw it up this way. I'll say about there. And if we follow the curve, let's follow it down this way. I'm going to say about there. So that's my attempt at drawing the tangent line. So if I look at this as close as I can tell, the best that we can estimate, it looks like there's a decent point right here. I'm going to call that 10 and 25. This is an estimate. We are estimating. We're looking at it and we're doing the best that we can with our estimate. And well, it's crossing the 20 here, so let's try that. So 20 and, well, it's not quite at the 30, so let's give it a little bit more, let's say 32. Again, estimating. We're getting as close as we can, we're estimating. And then we need to find the slope. So our slope, let's make this our x1, y1, so x2, y2. So substituting everything in, we would have y2, which we're estimating at 32. Minus y1, which is 25. X2 is 20. X1 is 10. So simplifying down, we get 7 over 10. So we're guessing that our slope is 0.7 centimeters per second per degree Celsius. See, this one has a compound unit right there, centimeters per second. And then we have our degrees Celsius here. So that's why we have our units like that. Let's look at the next one. A particle moves along a straight line with the equation of motion s of t equals f of t. Excuse me, s equals f of t, where s is measured in meters and t in seconds. Find the velocity and speed when t equals 5 of f of t equals 40t minus 6t squared. So there's a lot going on there. Let's take this down. Let's do one piece at a time. S of t right here, this is the position function. And we know its position because it's s and it's measured in meters. So that's the location, that's the position function. If we have the position function and we want the velocity and the speed, the derivative of position is velocity. So that's what we're hoping to find with the velocity and speed right here. The derivative of position is velocity. So let's take our derivative. So we know the derivative is the limit as h approaches 0 of f of a plus h minus f of a all over h. We're only taking the derivative one time. We're only looking at one particular value, and that is when t is 5. So I'm going to go ahead and replace the a with a t value of 5. So this will look like 5 plus h minus f of 5 all over h. We have a lot to figure out, so let's figure it out. I'll do it over here. So we have f of 5 plus h. So that'll look like 40 times 5 plus h minus 6 times 5 plus h quantity squared. So 5 plus h quantity squared really means 5 plus h times 5 plus h. And if we do that FOIL, we'll get 25 plus 10h plus h squared. So if we then distribute, we'll have 40 times 5 is 200. We need a little space. Let me scoot that over some. So 200. And then 40 times h is 40h. Minus 6 times 25 is 150. Minus 6 times 10h is negative 60h. And then negative 6 times h squared is negative 6h squared. We can clean it up a little bit. 200 minus 150 leaves us with 50. 40h minus 60h gives us negative 20h. And I think that's all we can do, minus 6h squared. Okay, so we got f of 5 plus h. Let's see if we can figure out f of 5 now. F of 5 means that we've replaced our t values with 5. So that will look like 40 times 5 minus 6 times 5 squared. 5 squared is 25. 25 times 6 is 150. So we'll look at 200 minus 150. So that's 50. All right, let's put it all back in. So now we're looking at the limit as h approaches 0. F of 5 plus h, that worked out to be 50 minus 20h minus 6h squared minus f of 5, so minus 50 right here, all over h. Now remember, anything that doesn't have an h has to cancel. So 50 and 50, I think that's it. So then we can say the limit as h approaches 0, we can pull out an h, and we're left with negative 20 minus 6h all over h. The h's will cancel. We've now eliminated our division by 0. So since we've eliminated our division by 0, we can put in the 0 from right here for our remaining h. So we'll have negative 20 minus 6 times 0, which will leave us with just negative 20. So this means that the velocity is negative 20. Well, velocity is negative 20 will translate to velocity is negative 20, and we have meters per second. Now, speed is the absolute value of velocity. So if we want to find the speed, we need to figure out what the absolute value of the velocity is. Let me write that down. So speed equals the absolute value of velocity. The difference is velocity has direction, forward, backwards, up, down, positive, negative. Speed does not. Think about driving the car. You can put the car in reverse, but your odometer is not going to go backwards. Your speedometer is not going to go backwards either. It's going to continue counting. You're going to have a distance driven. You're just driving it in reverse. So if we're looking at speed, we can go forward, we can go backward, but we can't go a negative speed. We can go a negative velocity, and that's the difference. So speed is the absolute value of velocity. So that means if the velocity is -20, then the speed is the absolute value of -20. So the speed is 20 meters per second.